All right, ladies and gentlemen, here we go. All right, today we're going to talk about finding a single population means using the student T distribution. Now, you guys ask lots of times, how do people come up with this stuff? And most of the time, I don't have an answer for you. All right, this one I thought was kind of interesting, so I actually remembered this one. All right, this guy, his name was William Gossett. All right, he was working in his brewery. And brewery is still around, and he ran into kind of a prediction problem. He was trying to figure out exactly how much he could produce, and he was working through the different math with it and all that, and he just couldn't get it to produce what he wanted to. So he started playing around with the numbers a little bit, and what he came across was that if the numbers worked based on the sample size. Now, if you think about that, when you're dealing with some kind of instruments, all right, if you change one of the variables, the whole thing is going to change. All right. So whether you change the ingredients, whether you change some of the how things are run inside that, all of those can have a major impact on it. So what he found out was the more he started to get more accurate results based on just the sample size. All right. So he didn't know if this was mathematically correct or anything, so he didn't want to put his name on it. He submitted it to one of the local colleges to have them to start to go over it, and he didn't put his name on it. He just put student on there. So this is legitimately called students T distribution, as I have here. All right, because he didn't want to take any credit for it because he didn't know if it was right or not. It ended up being right. Okay, lots of people verified it. Okay, and that is what we're going to go over today. Okay, so the nice thing is, if you have your calculators, we're going to be able to use them to be able to do a lot of this stuff today. All right, so get those out. We'll work on that in just a little bit here. Okay, but as it says up here, for properties of these T distributions. Now, first of all, a lot of these are going to be very, very similar to a normal distribution. That's what the first one says. The graph is similar to the standard normal curve. Okay, the mean. Yeah. The mean is 0, and the distribution is symmetric around 0. Okay, so that's important to know. Okay, as it says for the third one, the probability in the tails. So you know how at the very end there's very little left in a normal distribution. For a T distribution, okay, the tails can have more probability in them. So instead of being a very, very small one, it can be a little bit larger, but it is based on the degrees of freedom, which we'll talk about in just a little bit. Okay, so any questions with that stuff right now? All right, so different equations that you're going to need to do this.
Jack Huseman, please come to the office. Jack Huseman, please come to the office. Thank you.
All right, first thing that you have to know is you have to know the degrees of freedom. Degrees of freedom is simply the sample size minus 1. That's all it is, okay? From there, if you look at the rest of those equations up there, they're very, very similar to what we were doing with the other stuff that we've done, okay? It's just that degrees of freedom is always going to be n minus 1 with what we're dealing with here, okay? The EBM is very similar. The only differences are this was a z of a over 2. Okay, now it's a T. The only reason is because we're doing T distributions. How you figure it out, the exact same thing. All right, for this top here, this was, it's still the standard deviation. This one is the sample standard deviation. Okay, and then it's still over the square root of n here. Okay, and then Confidence interval, same thing as it was before. We take our average and subtract the EBM, and we add the EBM to get our lowest value and our highest value. So a lot of the stuff is exactly the same. It's just a little twist with our equations here, okay? All right, and then just after you get those down, we're just going to go through 2 different examples here. Yeah. And that's pretty much it for today. All right, are we ready to go? All right, so we have got a study with 15 different values here. Let's go, guys. Suppose you do a study of acupuncture to determine how effective it is in relieving pain. You measure sensory rates for 15 different people with the results listed below. Use the data to construct a 95% confidence interval for the mean sensory rate. All right, so get all that down. We're going to need those numbers to be able to do the math here. All right, but the nice thing is, calculator is going to do all the work for us this time. We just got to be able to make sure we put everything in the right spots. Okay, so like normal, I'll be able to catch most of your calculators. Autumn will figure it out a couple days afterwards, right? That would be normal. Okay, and Elena's, I think yours is a little bit different. Oh, you got a different one now. That's right.
Nice. These wouldn't be in order at all.
It doesn't matter if they're in order or not. It's just 15 different numbers.
Nice. I did that too. Nice. I don't know. Max gets breath. You were listening at Max house after prom, Max.
All right, we ready to go? Now, I'm going to show you how to put everything into the calculator first, and then I'll write down all the steps for you up there so you can get a good copy. Okay. So, first thing we have to do is we have to get all those numbers in the calculator. Okay. So, where you're going to go, you're going to hit the stat button. Okay. And then to put all those numbers in, we need to go to edit. All right. And then we're going to put it into our L1. Okay. For TI Inspires, it's a little bit different, but it's the same concept as we did before. Okay, and then you just get all of the numbers in there.
They have a voice. Is there?
I don't think so.
They're pretty. It's like this. It's like what? I couldn't.
So get all 15 of those numbers in there.
What, man? No, I don't care. You think I had something?
We can. Hey, put it away. Let's go.
Yeah.
All right, so once we get those in there, then we want the calculator to do the work for us, right?
Okay.
So from here, we're gonna go back to stat. We're gonna run a test here, so we're gonna go over to test. And then we're gonna go down to, yes, there's a t-test here, we're not gonna do that one. Okay, we're gonna go down to number 8 here, this t-interval. Don't know, I'm gonna have to work on that, on your guys's. Okay, so we hit enter for that. And then you should get to a screen like this. AutoCAD, any idea? Okay. Yours might take a little while again. Okay. All right, so after we get here, okay, we need to make sure that this data box is highlighted. All right, and then we're gonna go down to our list. If you put it in that first column there, that was L1, so I'm not gonna change mine there. All right, our frequency, we just had one of each one of those numbers, so we don't have, we just leave that as a 1. Our confidence level from the problem says we need to have 95% in there, so 0.95, and then we're ready to calculate it. This one does take a little while to get through, okay, but that's what you should get at the end. You guys got it?
Good job, man.
Okay, now, you're gonna have these numbers on your screen. Okay, what do you think these top 2 numbers are talking about here? That's your lowest and your highest, right? Okay, so there's the range, okay, for our confidence interval. X bar stands for what? The average of our sample, right? So all 15 of those numbers, that's our average. What is this number? Sample standard deviation, and then N is just how many numbers we had, right? And there were 15 numbers. What's that?
That's the degrees of freedom.
Okay, any questions?
Come on.
All right, so let's get, yes ma'am.
How do we know when to use this and not the lesson that we might get?
That is the next lesson. For today, we are always going to use this t-distribution, okay? Ladies and gentlemen, if you didn't hear Abigail, very good question. All right, she asked, when do we use this compared to what we did yesterday? All right, and that will be the next section, which we'll do on Friday. All right, for your homework today, it is most accurate to do the t-distribution. Okay, so if you want to get this in your notes for the process here, okay, first of all, you have to go to stat and then edit and then put all of those numbers into one column. All right, after that, then you're going to go back to stat. You are going to arrow over to tests. Go down to T interval. All right, once you get there, you press enter. And okay, then you make sure that your data is highlighted. Okay, your list is wherever you put the list in. Okay, so most of us default to L1, that's fine. Okay, after that, your frequency, because we only have one of each one of these numbers, frequency is 1. Okay, our C level is whatever our percentage is, just make sure you change it to a decimal. And then you hit calculate. And as we set up there, our 95% confidence interval is from 7.3 to 9.15. And that would be the answer for this one. Okay, that's pretty much it. You guys have any questions with what we're doing here? Okay, so what I want you to do, I want you guys to find the answer to this set. And there are 20 numbers in that list. How do we do? Did we get it? Eli, you think you got it, huh? Okay, what's your interval?
Wait, it's 90%. Oh my gosh.
117.41 to what? You sure about that?
Yeah.
Anybody else agree? Chances are you plugged in a number wrong. No, I mean, just off by a little bit. That's exactly what I got. So, all right, that should be correct. Okay. So, degrees of freedom. This one doesn't ask for degrees of freedom, but say a problem did ask for degrees of freedom. What would that answer be for it? 19. You just take however many samples you have. So we got 20 total. You subtract 1. That's it. Okay. Got it? Okay. All right. Now, the nice thing is, you know, you can figure this all out manually if you want to, but why would you if you have the calculator in front of you, right? So make sure you have that process down. All right. So then all of these equations that we were talking about back here, I mean, you could figure it all out based on this. All right. And it would be all the same as what we did the other day. Okay. There you go. That's the reason. Yes, you're right. That answers the question. Abigail, did you hear that? Okay. Okay. Caitlin just said, and this was right. Yesterday, what happened was we had sample standard deviation and we had sample mean and all of that stuff. All right. Today, what are we having? We're having actual numbers. So when you have the actual numbers, you're going to do the t-distribution. When you're just given the sample mean, sample standard deviation, then you use what we did on Monday. Okay? Any questions here? Pretty straightforward. We're going to keep it nice and short today. All right, so that you guys can get this stuff done. All right, your homework for today. 1 through 40? Sure, we can do that. Or we can do 8.2 would be from 38 to 621. All right, now most of these are quick and easy problems. All right, you just got to read through it, figure out what they're asking for, and then go from there.